What's up, guys? It's day 94 of programming every day, and today we're going to try to have a keyboard driver, for our operating system. But yesterday we left off. Oh, well, not yesterday. I did a little bit of, programming today, and I got it to print text without that weird, whatchamacallit, or whatever you call it, that weird spacing that was going on. I totally got rid of that, but we got color. We could change the background. Here, let me show you guys. If we need them into the kernel, kernel.c. Sorry guys, I'm on a new keyboard. We could change it to any color we want, and I think it goes up from like 4F, so we do 5F, and I'm not sure, but I think that's like purple. I might be wrong. We're about to find out. Yeah, it's purple, it's really cool. I gotta say, I'm pretty proud of myself that we're this far already. But today we're gonna try to get a keyboard driver working. I have no idea, so we're gonna watch a video on it to try to figure it out. And then after that, we'll print it to the screen. It'll be pretty cool. How to make a keyboard driver in C. Let's put this here so you guys could see it too. Here we go. Oh, and it's all stem again. This guy is the GOAT of just anything. So, okay, apparently we have to set up interrupts. So before we even get to the keyboard driver, this guy, we're going to learn how to do interrupts. So let me see. Yeah, we'll just watch interrupts and see if this does any different, because oh wait, we might have to do some utility work. Let me move this over here so I could show you guys what I'm doing. But this task state, I think we gotta get done before we do that. What is this? Create a task state segment. Task state segment. Let's see what this is all about. So is it to better, okay, wait. Is it to put it in long mode? Is that what we're doing? I don't quite understand. Why do I need TTS? Great question, because that's the one I'm asking. So I'm working on a multitasking system, one that would be expected of a microkernel. Basically, each process has a structure. Okay. So technically, what it is, right, is the same thing as processes. So you see all these processes running on my computer, right? Each one of these is a certain task running in my computer. So you see, we have our pulse audio. This gives me audio, or we guys see. Chromium task is running a bunch of tasks. Xorg is setting up our GUI. This whole thing is set up on Xorg. And let me see what else. Yeah, there's a bunch of stuff that process. So if we wanted something to run, say like a kernel, but you also wanted to run, say like you make a notepad app, right? You would need this. Now this makes sense. So I guess we gotta set this up first before we get anywhere near the other stuff. So let's see. Let's see what we can do. So right off the bat, seems like we have to set a descriptor table in here. Okay, first, after that, we'll just do the descriptor table. I already watched the video on this, and there's a bit of assembly that goes into it. So, but yeah, let's watch this video and kind of see what we have to do. So let me make this bigger so you guys could see it. Neovim GDT .c, and also let's make this more organized. Neovim, or not Neovim, we're going to create a new folder where we're going to store all our C files. So source, right, we're going to store all, not the make file, but all of these into source, kernel into source, boot into source, and yeah, that should be it. Okay, let me try this too. So I'll just delete all these. Let's delete those because we just want to make it prettier, right? And then I neovim into makefile. Oh, my bad, guys. Neovim into our makefile, and we put source. That should be it. I don't know if it creates. Let me make it real quick. Okay, so cool. So we make it a little more organized. Let me hit the space button. But yeah, okay. So that makes it so we're more, I don't know what you say, organized, yeah. Okay, so cd into source, we implement to do gdt, but h, we'll do h first, and we'll see what to do. So from what I'm reading here, I don't know why we need GDT, because wouldn't we already be in protected mode? Doesn't grub put you directly in? See, I just don't know. So first thing we'll do is include our stdint and h, and type def structure. Or not a type def, just a structure. And we're going to name it GDT entry, I guess. And uint 16t. This is going to be limit uint 16t base low, uint 16t base high, or base middle, uint 16t base, or not, or access. Sorry guys, I spelled it wrong. And then uint 16t flags, and then uint 8t, this is going to be base high. I don't know, let's do our research real quick, because I actually do want to know. Let's just make this full screen. What is limit in GDT? What is this a currency? Oh no, it's yeah, it is rupees. Sorry guys, I didn't mean to blow into the mic like that. I didn't mean to ear rape you guys. Yeah. Lock. It looks like Indian currency. That's not what we want. GDT descriptor table. I totally spelled that shit wrong. Okay, so we'll probably have to transfer into 64-bit mode. I think is what we're doing. 32-bit value, linear address where the segment begins. A 20-bit value tells the maximum addressed unit, either by 1 bit. So we're paging right now. I think that's what it's called, paging. Paging OS dev. I think we're paging. I think we're able to. Yeah, right here. Paging. Yeah, okay. So this is what we're doing. We're just paging, which is pretty cool. So why do we need paging? Let's look that out. Why should I page in OS dev? Because that's the question that I'm asking. In this system, user processes could only see and modify data which is paged in their own address space. So that's very important because it creates efficient, ways to handle our memory. So that's cool. So we have that. We create a new structure called our pointer structure. Because I guess we got to point to that memory. That makes sense. But well, let's look this up because I'm curious. Attributes. Let's see. What does this mean? It's not part of C, but it's an extension of GCC that allows you to convey special information to the compiler. Tells the computer to pack the structure memories as tightly as possible, potentially reducing the structure size. Interesting. I didn't know that. So we're going to do UN 16T. It's going to be limit and then unsigned int base. So what does unassigned mean? Because I don't know. Those are the values that are non-negative. Okay. So honestly, guys, I don't know. And I'm sorry I keep blowing on the mic, guys. That's just me being goofy. So then we do the attribute and then packed, or it's in 2. Right. And then we call a function that we are going to declare init g and then void set gate. This is going to be u in 32t num. It's going to be u in 32 base, u in 32 limit. Limit or base u int 32. What is going to be u int 32 limit, and then let's see, there's another one, access u int 32t access, or or this one's 8. It's going to be an 8-bit integer. Access, and then uint 8t. This one's going to be called gran. I don't know what that means, but hey, we're about to find out. So yeah, that's that. Now we're done with our H file. We have to create neovim gdt.c. Now here we include our gdt.h, and then here we extern. What is this function? I'm guessing we'll have to do interesting. So I don't know what that's about. We have our struct, and what do we call that? gdt.c or h. We called it we initialize our structures. So sorry guys. dt.c, we create a structure of gdt or file, or what did I say? gdt. Did I say entry? I call it gdt entry and then pointer structure. Okay. And we create struct gdt entries. We're gonna make it 5 bits. And struct pointer struct, or I guess this is just pt pointers, right? And then we're going to declare our init function, right? We're going to initialize gdt, and then gdt dot or gt or pointer struct, or what am I saying? ptrs dot limit equals the size of our struct of gd. So the value of 5 is technically what this is going to be, which is pretty cool. Oh no, I was wrong. What is going on? Okay, so we got the limit, and we're gonna make it gdt entry struct times 5 minus 1. Okay, and then pointer dot base equals address of gdt entries. So it's a pointer, right? And then set gdt gate to 0, 0. So this is our null segment. Okay, our null segment. And let's see if all this runs. So I go to neovim makefile. This should all work because there's no. Oh, shit. cut that out. Then we want to compile it again. So this, that's a VGA gdt.o gdt.c. We make, and then make it set gate. gdt.c, or what did I set it to? gdt.h. Sorry guys, set gate. Jeez, I'm sorry guys. So set, this would just be set gate. So set the gate, and we set our gate again to these random values. So 1, 0, 0x, 1, 8, 0x, 9a, and 0x, cf. I don't know. I'm guessing those are just addresses that I have to set to. Set gate u int 32t num it's going to be base 32t limit, and this one's going to be u int, this is going to be 8t access, and then u int 30 or 8. This one's going to be 8t, and it's going to be grand. I don't know why. Okay, so that's that for that segment. Oh, okay. So this is the kernel segment, or this is going to be, you know, where the kernel is run at. Okay. Oh, okay, so I gotta, this is kind of just setting privilege. So, must be set to 1 for any valid segment. The highest privilege is the kernel, which equals 0. 3 is the lowest privilege, user applications. Interesting. It's really cool, guys. I'm like, so for data selectors, direction bit, if clear 0, the segment grows up. If segment 1, the segment grows down. The offset has greater, must be, or has to be greater than the other one. Interesting. Interesting. No, I don't know, guys. Why would it be like that? I don't know. And hold up, guys, let me figure this out. I gotta do the, set my volume control to my, headset. Playback, output devices, it's gonna be my, so say I go to Chromium, or say I want to here. Sorry guys, I want to see if my audio is the correct thing, because I don't want to be like, you know, destroying your guys' ears. That's not it. It's right here. Let me see. So playback, media player. Okay, so we're good. We're good. We're good. We're good, guys. So, okay, let's get back to it. So, it seems like, see, that's interesting. But now we have to create 3 of these. We have to create 3 of these. Copy, or let's cut it out, because copy doesn't really work. This needs to be 2, and then these could be 1. This would be 9, 2, and then I think that's really it. Now, what I'm confused about, see, we're almost, sorry guys, and I know my computer's acting, I'm sorry guys, ignore my computer. I know you guys said that in the last video it was loud. I'm so sorry about that, guys. There's nothing I can really do about it. My computer's just really loud. And we got, after this, we got, this would be FA, and this one would be F2. F2, and then the 3 or 4. Like this, and then we flush it. Oh, I didn't mean a page down. Our address of our pointers. Hold up, guys. Who called me? Hold up, guys. Give me a sec. Bro. Sorry guys, I gotta take this.
Hello?
Hey, what's up? Yeah. Okay, wait, hold up. Hey, hold up, I'm programming real quick. I'll call you guys, or, yeah, here. Bye guys. Sorry about that, y'all. That was my sister. Okay. So back to it. So this is going to be the last. So GDT entries. This will be how many processes we have. So this will be our number. Dot base low. So these are our entries. So every time we open up a process, I'm guessing we have to open up, you know, this thing, and then this will be different memory addresses, etc. Equals base. Zero x f. Okay, so now we just copy this. That's not what I wanted. No, we'll just type it out. Typing everything out usually helps you remember things better. So our number dot, this will be our base middle, equals, this will be our base 16, and then 0xff. So then now one more num dot base high equals base 24, and then the address 0f ff. Okay, cool. And then we do our limit and all that. Okay, so then we have to fill out all the rest of the entries. So gdt entries num dot limit equals our limit address. Now, if I'm being honest, none of this makes sense to me, but it will make sense to me, because I'm just gonna keep doing it until I understand it. Which listen. So, you guys might see me build more. Once after this project, I might build more in the future. Once you build it first, it always gets easier because you know how to do it. Limit. This is gonna be. It's gonna be. And then 16, and then the address 0x0f, right? Yep. And then gdt, that's gonna be the last one. Entries num dot flags. Oh, what was this? Assuming we're built-in operators in integer or singly overrated operator. Big advantage is when A is itself a complex expression. So what does it do? Oh, it'd be gdt entry flags if, okay. So come off. Okay, makes sense. Makes sense. So we got our and this at symbol 0x0f or f0 for this one. Okay, cool. So now gdt trees number dot access equals access. Okay. Now that should be everything for this. Now we got to create gdt.s for assembly, global, our flush variable, or what did I name it? gdt.c. So I named it gdt flush. So that's what I gotta name it. gdt.s global gdt.flush. Cool. Okay, so then we do gdt flush. So technically we're calling this assembly command, right? So move edx or eax to esp plus 4, so offset of 4, and then move. Or no, this isn't move. This is L G D T. It's global descriptor table. Interesting. So that, then we move. Let's sort this out. Move EAX to the 10th interrupt, and then we move DS into AX, and then move ES into AX, and then move, or actually this is, yeah, ES FS into AX, then GS, and then XS. To AX. Okay. And then we jump 0x08 to dot flush. And dot flush. You return. That should be it. Now we need to go back, so give him our make file, and we gotta call. We gotta call it in here. So let me get an elf file. So nasm-elf32 source / gdt.s -o gdt s.o for assembly, and then we plug it back into here, gdts.o, and then gdt.o. Yeah, okay. Make it. Oh my gosh. Oh my gosh. Okay. 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 So clearly, we did something wrong. Let's see what we did wrong. Sorry if you guys can hear my computer. I don't. I'll try to get that fixed. I don't know how to be honest. So let's figure this out. So the first error, as it turns out, we're missing parameter name. So CD into source, CD into VGA, not VGA, GDT.C or F or C or F or C. Sorry guys, .c. Okay. So it looks like we forgot a comma somewhere. Or is that supposed to be a comma? No comma there. We need a comma here. Wait, no, comma here. Right? Hold on, let me make sure.
Set our GDT game.
Entries over here. think that's where we're gonna end it today, guys. I'll do more research tomorrow before I get back to y'all. But I will see you guys tomorrow. Thank you guys for watching. Bye, guys.